Welcome to my YouTube channel. My name is Supriya Patil and today I am going to cover a topic of engineering chemistry, that is Boyle's calorimeter. So without any delay, let's get started. So the principle. The Boyle's calorimeter operates on the principle of measuring the heat released during the combustion of gas by using water as a heat absorber and measuring the temperature change of the water. So see here the construction in which gases or volatile liquids are taken as an input, and to measure the volume of the gas meter is joined to this pipe. To burn these gases, burner is attached to the same pipe, and here is a combustion chamber in which combustion of these gases takes place, and this combustion chamber is surrounded by this chimney. Here are two thermometers are used, one to measure the temperature of incoming water and another to measure the temperature of outgoing water, and this whole setup is covered with this insulating jacket to prevent any type of heat. So here is this water coil of copper is surrounded to this chimney like this, and this copper coils of water enters and surround to this combustion chamber like this to measure or absorb the heat by the water which was released by this combustion of these gases. So this is a simple construction of the Boyle's calorimeter. Let's see the working, in which the Boyle's calorimeter works by burning a known volume of gas in a combustion chamber and measuring the heat absorbed by a circulating stream of water. This absorbed heat is then used to calculate the calorific value of the gas. The calorimeter consists of a gas burner, combustion chamber, and a surrounding water jacket with inlet and outlet thermometer. Here is a more detailed breakdown. Let's see. First is the combustion. A known volume of a gas being tested is burned within the calorimeter's combustion chamber. Heat absorption. The heat released by the combustion process is absorbed by the cooling water circulating through the calorimeter's water jacket. And the thermometer's measurement. The temperature of the water entering and leaving the water jacket are measured using the thermometer. And the calculations. The difference in temperature, the mass flow rate of the water, and the volume of gas burned are used in a formula to calculate a calorific value of the gas. So see here, as the gases or volatile liquids enter through this burner, they are burned and release heat, and the burn gases and the combustion of this fuel takes place in this combustion chamber. After the burning of gases, heat is released by the burning of these gases, and which is present inside this combustion chamber and somewhat in this outer part of this combustion chamber. So here are water inlet is provided, and this water inlet is surrounded like this to the chimney, and then it enters and surround to this combustion chamber. It is used so that water can absorb the heat released by the gases or liquid fuels, and after water absorb the heat released by the gases or volatile liquids, the temperature of this water can increase, and the temperature increase can be measured in this thermometer, and then the water is taken out. Like that, we can measure the difference in the temperature of the water from the incoming water and outgoing water, from which we can understand and calculate the amount of heat released by this fuel. So see here the formula for calculating calorific value by Boyle's calorimeter. So HCV is equal to W into T2 minus T1 divided by phi. Here HCV stands for higher calorific value and W is equal to weight of the water heated. Here T2 minus T1 is the changing temperature of the water, and phi represents the volume of gas used. Here a LCV. LCV represents, this stands for lower calorific value. It is also called as net calorific value, and the HCV is also called as gross calorific value, in which LCV is calculated as HCV minus m divided by phi into 587, in which m divided by phi. M is the weight of steam condensed and phi is the volume of gas used. So this is a standard formula for calculating the calorific value. So see here one of the numerical in which volume of gas is given as 0.10 meter cube, mass of water is 30 kg, inlet temperature is 25 degrees Celsius, outlet temperature is 37 degrees Celsius, condensed steam is 0.045 kg, and latent heat, which is constant, that is 587 kilocalorie per kg. So here we have to calculate the gross or HCV value, which is called the gross calorific value, and the net calorific value. So see here Q1. Q1 is equal to 13 into 37 minus 25, which is 30 is the mass of water, and here is the changing temperature, which gives Q1, and here is the Q2, that is 0.045, which is a condensed steam, into 587 is a latent heat, which gives 26.42, and by this Q1 and Q2 we can calculate. Q is equal to 360, that is Q1, and 26.42, which is Q2. So the Q is equal to Q1 plus Q2, that is equal to 386.42 kilocalorie. And to calculate gross calorific value GCV, we need Q value divided by volume of the gas. Here see the GCV, which gives 3864.2 kilocalorie per meter cube. So this is our GCV or calorific value, gross calorific value. And to calculate NCV, we can use formula GCV minus M divided by V into 587. We can get NCV value, that is 3600 kilocalorie per meter cube. So this is a simple numerical based on the Boyle's calorimeter to calculate a calorific value of these gases. So see here the advantages and disadvantages of this Boyle's calorimeter. So advantages are relatively simple to use. Voice calorimeters can be operated by non-experts. Accurate heat flow measurements. They can measure heat flow with high degree of precision. Wide range of heat flow measurement. They can handle both small and large heat flow. So this is also one of the advantage, and the cost effective compared to some other calorimeter method like bomb calorimeter. Voice calorimeters can be more affordable. So these are some advantages, and here are some few disadvantages also, which can be like may not be as accurate as other calorimeter methods for certain applications. Other methods like bomb calorimeter might obtain higher accuracy. And second is limited to gaseous fuels. Boyle's calorimeters are primarily designed for gaseous fuels analysis. Potential for heat losses. Some heat may be lost to the surrounding, potentially affecting accuracy. And the last one is a maintenance. Regular maintenance and calibration may be needed to ensure the accurate result. So these are some disadvantages of Boyle's calorimeter. So here our topic is ended. So thank you so much for watching this video.